My name is Johannes Eichstädt. I'm faculty here at HAI, and I am really delighted today to welcome you and to welcome our presenter, Andy Schwartz. Andy is an assistant professor at Stony Brook University, where he runs the Human Language Analysis Beings Lab. Andy, so modern science, it's often said, evolves at the interstitial points between disciplines, in between disciplines. And I think in natural language processing and the social sciences, that is particularly true. There's been a lot of innovation and breakthrough and interesting applications at the intersection. And Andy co-founded the World Wellbeing Project about 10 years ago with myself and another Penn faculty. And since then has been working on introducing social science applications to natural language processing. And over the years has really emerged as a leader in that community and has introduced lots of problems from the social sciences into computer science and natural language processing as shared tasks. They span clinical psychology questions, they span the measurement of well-being, and more technical questions about how we can make natural language processing better by learning about people and learning from the social sciences. And it's been my delight to work with Andy for almost a decade now. And I'm particularly delighted to welcome him here today and hear about his framing about where the field is going and where the field has been. Thank you very much. Welcome again. Oh, and I should say, if you have questions, there's a Slido link where you can submit them and I shall moderate throughout. We'll probably save the questions until the very end, unless it's a clarification questions, in which I'm more than happy to talk over Andy and ask him. So welcome, Andy, and take it away.
Thank you, Johannes. And I really appreciate the invitation to talk to the Human-Centered AI Institute. Let me just jump right in. I'm going to be talking today about work that covers between natural language processing and psychological and health sciences. And this is mostly work coming out of my lab, the Human Language Analysis Beings, a lot of it done by these folks here. Not all of them from my lab, but these are PhD students: Veronica Lin, recent graduate, MZ Zamani, Young Salsan are current PhD students. Vivek Kulkarni graduated just a little while ago. He's actually with you guys at Stanford lately. Salvatore Giorgi, who's a current PhD student at Penn, ready at a Bibi, who's a recent graduate who was a graduate student with us. And it's been in collaboration with a lot of other folks from other disciplines, of course, including Johannes Eichstädt, a lot of other social scientists, as well as natural language processing folks that are interested in the intersection of these two fields. Now, a lot of our work focuses on taking natural language processing and basically goes in this direction, applying natural language processing to psychological and health sciences. And that's actually what most of the time I'll talk about. I'd say 2/3 of the time, 2/3 of our work probably goes in that direction. And some examples of that, though, as I understand, because you, Johannes Eichstädt is part of your group, he's presented some of this recently, as I understand. But a lot of this work focuses, for example, some of the earliest work we looked at personality, associated word use associated with personality. And so here we see the words and phrases associated with extroversion, people that are more inclined to socialize or that feel more energized after socializing. The size of the word is its actual correlation strength, how predictive it is of being an extrovert, and the color is its relative frequency. Hit me up, for example, is very predictive of being an extrovert, but it's not very common, whereas love you is also predictive, but it is common. My favorite one here is the exclamation marks. It actually turns out this is only the top 100, but 2 exclamation marks and 1 exclamation mark are also predictive. It's as you add more exclamation marks, there's a greater and greater association with extroversion until you get to 3. And then when you go to 4, I think they start to signal something different, perhaps anger. And of course, on the computer science side, we love the opposite end of the spectrum. At least that's my experience. Well, because introverts, the other side, are of course focused on computers and a lot of solitary activities, reading, and but also internet. But also what we see in here is some things come out when we do these analyses that are unexpected, but perhaps post hoc made a lot of sense. Like, well, there's a lot of discussion of Japanese related culture, anime, and whatnot. So this is kind of just a sampling, and this is going to tie back in. There's a reason I'm showing this, although this talk we're going to be actually looking more at natural language processing itself. Just as another example of something more recent that we've done, we looked at tweets coming out from users' timelines before a hospital visit. And we looked at how their language changed before the visit. And we compared that to their language change at what we'd call a null event, when they didn't have a hospital visit. And for example, we saw things like an increase in anxious language, an increase in depressive language, and at the same time, a decrease in self-references, which is kind of interesting because some of you may know depression and self-references go together, but in this case, people tend to get more we-focused when they have a little bit of medical distress, is the theory behind that. A little bit more family and relationship focused. And they also get less informal. Social media becomes less laugh out louds, less slang. But today I'm really actually delighted because this is one of the first times I've really done a big picture talk where we're going to focus the other direction and how to apply psychological and health sciences to natural language processing. And now I say how to apply, I mean just perhaps some ongoing work that suggests where there's a lot of room for improving our NLP systems based on psychological and health sciences. And so one example in this direction, actually before, just clear that drawing off of there. So before I get to that, because I'm speaking to the human-centered folks that are the Human-Centered AI Institute, I feel I need to put this up. Okay, and so here it is. Fill in the blank of this sentence. No, not people. X to the T. Actually, it is people, or as I like to call them, human beings. But I get a lot of flack from my social science colleagues for calling people humans. But the point is, okay, natural language is generated by people, and that's what we're focusing on in natural language processing. And people have different beliefs, backgrounds, styles, vocabularies, preferences, knowledge, personalities. Lots of things distinguish us. And when we look at people's language, I mean, there's now, probably going back at least a century of evidence that people's language reflects a lot of these differences. And in fact, a lot of the, the work going in the opposite direction leverages that. When we're trying to understand people's personality, understand people's mental health from their language, we have to leverage that fact. And actually, this isn't even that new of an idea. I want to point out to natural language processing. Claude Shannon, back with some of the very first, some might say some of the first work in NLP, understanding the distribution of words, used in communication between people. Mosteller and Wallace looked at the Federalist Papers, classic work trying to identify the author of the Federalist Papers. The goal in the end wasn't just to model the words, but to model them with respect to different author styles. Clark and Schober have this great quote: "The common misconception is that language has got to do with words and what they mean. It does not. It has to do with people and what they mean." And there's really been a lot of additional people working in this area, Marilyn Walker, and for example, most recently, Hovey. I'm definitely leaving out people. In fact, we could probably throw most linguists into the bucket who have ever gotten involved in computational linguistics or natural language processing. Almost always insist, keep in mind, you know, people are writing this. Language exists in a social context, the context of the person who's speaking, and the social context it's being spoken within. And yet, though, still our models look something like this. We've got our documents coming in, sequences of words often going through our models, getting more and more complex. And, you know, typically this is, of course, just a little bit of an generalization, but typically then class probabilities coming out summarizes a lot of the work we do. Our models take in the words, work with those class probabilities, and often within the models, they're not explicitly trying to leverage the fact that the words come from the person. So, you know, an example of such a task: document classification, detecting the stance of documents, of tweets. Pro-gun control, for example, yes or no. How do we integrate this information about people into our models? How do we adapt them to the human level? Okay, I'm seeing hand raises, by the way. I just want to make sure I'm to go on and not.
You are to ignore them.
Okay.
If people have questions, please post them on Slido. You can see the link in the chat, and you can also see there's a link also on the webpage for the talk and your email. Keep going, Andy.
Okay. So how do we do that? Well, it's not entirely clear why we're not leveraging this idea, even though it's been around a long time. And I mean, I think it's a complex problem. In the end, it's probably a psychological social science problem too, dealing with mixing of fields and you know, some complexities, and being used to discrete data and computer science, and psychological science having to deal with a lot of things that can never be measured perfectly, objectively, and yet they're still extremely useful, extremely, you know, sometimes of critical importance when it comes to mental health. But I also think we often just don't, maybe the attributes feel a bit elusive, and yet they shouldn't, because the language itself is often telling us a lot about the individual person. In fact, sometimes in a more personalized way than, for example, just taking their gender, class, what that would tell you. You know, taking some other coarse-grained information about a user. And I'm going to use, I apologize, I'm going to talk about people interchangeably a bit as users, depending on whether we're talking about them in the context of language on a service or not. And but and the end users are, you know, are people that are very complex and embedded in these social situations. And so here's an example of some of the types of information that we now is pretty well founded that we can establish from individuals' language, at least to a degree that's useful, that's been shown to be applicable to predicting, you know, for example, users' behaviors, so, such as personality, demographics, emotional states, political ideology, and then more broadly, linguistic style. Couldn't do a presentation without mentioning Jamie Pennybaker's work, not really from the natural language processing side, but has definitely pioneered from the psychological side the power of what people's language use patterns tell us about them. And even latent user traits from people's language. Okay, you can even go broadly. Doesn't have to be, you don't have to subscribe to a particular theoretical background, even using just what are the latent dimensions that separate people. And so we been interested in this question of involving the person into our models. And we asked if we could take this to the extreme and just say, what if, to kind of ask how much does the user matter? What if we actually tried to get rid of the actual document being classified? Okay, so we took this task, document classification, stance detection, okay? Gun control was one of the stances, Hillary Clinton was another, there was a few others, abortion. And the goal is to read the tweet and say, is it pro or against this given content area? Okay. And what we did is we said, well, let's actually ignore the tweet. Let's throw out the particular tweet being classified, and let's just look at the user attributes, okay? Which we can actually get from, well, not that tweet itself, but we can get characterizations of the user from their past tweets. But we're going to ignore the actual tweet that the task is on. And we said, how well could we do with this? Okay, so here's, it actually turns out to be a fairly difficult task to beat the most frequent class, baseline. Both sides, a lot of the keywords can only give you so much improvement over the most frequent class baseline. And so the top SimEval participant had a 4%, a little bit over 4% error reduction. And we found that when we used a combination of user information, but we didn't even look at the tweet, only user information that was available before the tweet, by the way, we were able to get a I believe it was like a 7.5% error reduction, and a significant improvement over the SimEval top participant. And in fact, so that was still using quite a bit of features about the user's background. And so we decided to take this to a more extreme position, and we decided to just use 5 factors of latent user traits based on a background of language. And so only using 5 inferred factors, we were able to basically replicate the same performance of the SimEval top participant. Now, of course, the task is about predicting the tweet, but at the same time, stance, I think you have to think about, is that a document attribute or is it the person's attribute? Maybe you'd like stance detection of a tweet to respond to the tweet. You wouldn't want a person's stance to remain stagnant. You'd want a system that can adapt as a person's stance changes. But even when we just assume, we have a system here that can't do that. This system that doesn't do that, and it does better than using the tweet itself. So just kind of to emphasize the extent.
Andy, there's a question about what features you use for the prediction of the latent traits of the people. Is it just words or what?
Very good. And it's 1 to 3 grams. It's words and phrases that were factor analyzed in this paper by Vivek Kulkarni, 2018, latent human traits in the language of social media. And it was actually on a different data. These latent traits that were actually formed on a different data set, didn't overlap. So these latent factors weren't inferred over even the users of the Twitter data set. They were actually inferred from status updates. So we take a big set of everyone's words and phrases, and we basically, our model that was inferred from other data reduces that down from a large set of people's language to a small set of just five dimensions. But that's done in a completely unsupervised fashion for this task. That was even out of sample based on the data.
And of the latent traits, which one would you say are the most important?
Well, when we identify them, so I will say our approach in the Kulkarni paper of identifying these latent traits was not to try to describe them theoretically. That's an ongoing work right now. But when it comes to theoretical features, I mean, definitely demographics, socioeconomic status, which are, known in general to be the standard, as I was early on instructed by my social science colleagues. These are the standard things that you correct for often in your psychological studies, seem to also be those that have the strongest associations. So that's demographics and basically socioeconomic status. Then I'd say when you go beyond that, you might say those aren't quite psychological factors yet. We do see personality. Generally, it never is the best, but it's the most, in my opinion, over a lot of different outcomes predicted from user attributes. Personality is the most consistent. So let's go in a different direction. Okay, so that's doing actually document classification. Let's say we are trying to predict something about the person. Coppersmith, Dreads et al. Set up this nice task back in 2015, one of the first shared tasks to try to get at, can we assess mental health from social media data? And when this task before, a lot of people don't realize this, because by the time it was set up, the latent user attributes were corrected for. But when it was first being developed, they held a kind of small competition. And what happened during the small competition is specifically the task of distinguishing PTSD from depression. This is a differential diagnosis task, very difficult. In some schools of thought, it's, there's a continuum space where there's no clear boundaries between these two. And so when we looked at their tweets, and we saw we were getting a 0.84 correlation. I mean, a 0.84 accuracy, which is very high. That's saying the true positive to false positive rate is extremely high. That's more than you'd expect, a clinician, for example, to agree with a set of other clinicians, even for this particular type of task. But it turned out when we looked at the age distribution, and again, this is predicted age distribution. So it actually is shrunken a little bit. We saw that just comparing the depressed users to the PTSD, there was a huge separation simply in this one factor in this case. In fact, age alone was accounting for, if all you did was predict one variable and it was the age of the person, it was accounting for most of this difference. And so the organizers of this task, actually responding to that, went ahead and made age and gender controls, match controls for every person. And so that equalized the distributions here and allowed us to focus on, in this case, where the language can actually make a difference. The assumption is most cases where you'd actually want to use this, somebody's age would already be available. And so if all you're doing is producing something that could have been done with, one variable, that's not going to be very useful. And so finally, a third example. And coming back to this idea, natural language is generated by people. Let's go in a different direction. Let's look at these tweets here. What are people, let's take a second to read these tweets. And think about, I don't know, if you feel like a friend of yours could have sent them. Or maybe a younger, I don't know the exact age demographics I'm talking to. I do at least feel like this would be perhaps or maybe even when I was younger, in a set of tweets. Well, it turns out these tweets are actually sent by a social bot, a social spam bot. You may be aware that this article here summarizes within about the last 5 years, the spam bot technology has been becoming more and more advanced. It's no longer, the goal is to try to basically resemble people. And so there's, of course, this task of can we identify these social spam bots, these impersonators, Twitter users that are actually just bots. And so we thought, well, let's look at this. Let's consider, well, what would be the actual attributes of the spam bots? We first looked at, well, real users. Okay. This is using this one of the data sets described in this paper, Cressy et al. And we this is the distribution, for example, of age of Twitter users according to our predictions from our language model. Pretty similar to what you could find, for example, the Pew survey of internet users. This is about at 24, 25 or so. It tends to peak, and then it's skewed young. And then we said, well, what about the, what if we take the spam bots, not humans, and let's just pretend they're human. Okay, let's predict their distribution of human traits and look at what that looks like. I mean, they look, if you just read their language, I think, and actually they have some evidence that most people actually can't easily tell the difference when they're just reading the tweets. But if you take the tweets and predict, for example, their age, this is what you get. The spam bots are mostly clustered. This is somewhere around 30 years old, according to their language prediction. They're all extremely similar in this range. And these are, both of these have the same area under them. These are equally sampled distributions. And in fact, if we look at their gender, okay, we have a model that predicts people's gender from their language that does a continuous gendered score. I wish we had one that did more than one dimension, but it goes from, just don't think great data for that, but this goes from more male to more female. This is actually in the form of a lexicon that's publicly available, by the way. It's on wwbp.org. And similarly, the spam bots were slightly male, just slightly male, and had a much less variance in their language. And in fact, we looked at a lot of factors about them, not just age and gender, positivity, negativity, the big 5 emotions, the emotion lexica from Muhammad et al. And in every single case, the spam bots had a much shallower distribution of, a much steeper, I should say, much less variance. In fact, you might even go to say that they have a lack of personality, and that there's very little difference from one to the next when you look at it from these human dimensions. When you treat them as humans and say, well, how are they distinguished on these human dimensions? They're not. They're distinguished in that they're surprisingly not very different. Maybe one thing, positive. Positive was the one thing where they stuck out as clearly separated from people. Johannes?
This is really cool.
Oh. I thought you were going to ask a question. Yeah, we were actually shocked when we saw this. We thought this would just be a fun study. So Sal ran this study. He's the real person pictured here, and this is in preparation actually now, but we're quite excited about it. One of those kind of side studies that ends up being more fascinating than we ever thought. We didn't expect this, and in fact, we weren't even going to try the task. We just wanted to look at their human dimensions. But once we saw this, okay, and we ran this over their larger training set of data, we said, let's go ahead and attempt the task using these 17 variables, let's try to predict. Okay, human annotators, according to the social spambot task, can only get it right 57% of the time. Bot or not, which is a bit of an older system, 76. Ahmed and Cressy, which had the state of the art, at least as of about a year or so ago, they're using techniques like this, that's using network graphs, the temporal timing of the tweets, sentiment, all sorts of features. Although some of them are human level. Ahmed's model uses quite a bit of human level type information. They got up to 0.92. We took our predictions, noticing that a linear model obviously wasn't going to work because you need to see if something's in a range. We threw it in the simplest nonlinear model, that's people use these days, a random forest, and just 17 human factors, and we actually got a significant improvement over these other models.
That is super impressive. I should just add some commentary here for our diverse audience. To outperform a state-of-the-art classification accuracy like this is generally reported with 3 significant digits. It's by the time you get from 92% to 92.1%, you consider that a great contribution or a worthwhile contribution. So the fact that just looking at different feature spaces gives this kind of contribution is very, very clever. And it really shows the power of considering the human dimension of language, not just language in and of itself.
Yeah, and it's kind of, in this case, if you think about it, it's now we're using the human dimension, but applying it to bots. Now, I should also just to hedge, to be clear, this is as of this data set this is as of I believe about a year ago, and as I said, this is late in preparation work. It could be that people have, in the meantime, also boosted this a bit, but at the time of about a year or so when this task is presented by Cressy et al. Mm-hmm. And in fact, we did the same sort of thing of saying, well, let's just look at, smaller sets of features. And to that question earlier, we looked at personality scores and just the 5 factors. And those alone even gave us a 0.9, well above the human baseline and of the bot or not system. Okay, so what this maybe gives some ideas of how the human attributes behind the text, the people behind the text, modeling the people behind the text can give us some power. What does this mean? Let's try to disentangle what's going on here, maybe a little bit more technically. And I think we can break it down into three main points. First is our data are inherently multi-level, and we can leverage that. Second is there's often already available human attributes that are also available, that are also able to be leveraged to improve our systems. And the third is that our data and our models have human biases. These two actually kind of go hand in hand. Once you've taken this into account, it's much easier to address these biases. So talking about the multi-level aspect, what I'm referring to is this idea that documents, okay, what we're usually working with, documents, sentences, we'll just generically call them documents, are generated by people, and people belong to communities. And so just as kind of a simple way to understand this, we took tweets, about 1.5 million tweets written by about 5,200 users from 420 counties. This is from a Volkova data set looking at demographics of users. We looked at these and we wanted to look at, well, how does the distribution of language change? We know that this is a distribution plot of word use at the document level. I'm sure many of you are familiar with, the Zipfian distribution in general, the power law distribution, and it's fairly well established that documents have something along this shape of the frequency of a word use. There's a few words, very few words that get used more often. Things like the, it's at the top of the distribution, and other words that get used hardly at all. And in fact, this line here represents the proportion that are not used at all, right? So this is, you can interpret this density as, given a random document, what's the probability that a given word is mentioned this frequency of time, and just astronomically larger probability that any random word, I should say this is among the top 20 most common words in English. Any random word is of course not, is more than likely to not be mentioned at all. That's well known. That's the sparsity problem. We've been in LP addressing that for a long time. Now, what happens though when you go to the user level? Because users are writing multiple documents. Well, a word like the now starts to look normal. Okay, it still has, some users just don't use the, but for those that do, it's normal. And then love is starting, but it still has kind of this power law shape. Okay, at the user level, some users are using it a lot. Most of them are using it very little, relative to the, at least. Then when we go to the county level, we see actually by this point, because we've got these on the same scale, maybe it's not that obvious, but both words actually have a normal, now have a normal distribution across at the county level across the United States. And so now you've aggregated through documents, through people, to counties. You're getting more and more accurate, and the sparsity problem, at least for common words, it's not really prevalent at all. And in fact, when we look at just going from power law to log normal to normal distribution, we looked at which distributions were best fit at these three levels of analysis, and we saw that it just went cleanly, nicely from a power law to a normal distribution, basically following the central limit theorem as we got more and more aggregate. These 1 grams topic lexica, these are features that are getting more and more aggregate, and then these levels of analysis are getting more and more aggregate. And so we've leveraged this recently. I have a paper coming out in the ACL this year, leveraging it within a deep architecture with message level and user level attention. And we've been able to get state-of-the-art prediction accuracies for, this is the personality prediction compared to some past work we had done. But you actually don't even have to do, so I think there's a lot of opportunities at this level, of course. And there's other folks, some folks out of Colorado starting to do some similar stuff with deep user factor adaptation. And when we look, also I should mention, just to understand kind of what's going on here, if we look at like the attention scores across such a model, we're able to, there's both a utility to having message level attention, we show in this paper, and word level attention. And you get things like, these are some of the lower attention words associated with conscientiousness. Conscientiousness is actually predictive, the swear word damn it is actually associated with lower conscientiousness if you just look at it by itself. And the model seems to pick up on, let's weight this message lower, even though it has a word that's important for conscientiousness. Of course, there's this is just for kind of exploration. There's a lot of recent work, saying you got to be careful how much you interpret attention. But you don't even have to do something so complicated. You can, here instead, we just kind of leverage the fact that the data are multi-level. For a while, we've been working on predicting the life satisfaction of communities, the well-being of communities across the US by looking at their tweets. Okay, and we usually do this, we try to keep pretty simple models because we want to share these widely and for people to understand them. Plus, by the time you aggregate so much, it's hard to get a lot out of it. And our typical models, we're performing at about a 0.35 correlation with a assessment from Gallup surveys where they call up, actually these were CDC surveys where they call up a bunch of people living in the counties, and we look at how our models correlate with that. So here, though, we applied this idea and looked and broke, instead of just treating counties as basically bags of tweets, we looked at it as, well, counties are made up of people. And we first aggregated tweets to people, and then we aggregated tweets to counties. You note that this mirrors very heavily how surveys are done. You know, each person you'd hope to survey across people, you utilize sampling statistics. And simply just by doing this aggregation effect, we got a large improvement from 0.33, I believe it was, to about 0.45, and our accuracy at predicting life satisfaction at the community level. So much so that the reviewers let us keep the word remarkable in the title, which is usually unusual to have an adjective. This paper describes, this data set is actually at the aggregate level, is actually available for anybody to use, and that's this paper describes that. Okay, so some of the questions, some of the discussion early on, I think I'm aiming for 5 more minutes, and so I have a couple more points to go through.
You have time, Andy. I think the questions that have stacked up here will not take more than 5 minutes.
Okay. So let's talk a bit more then about this other point of utilizing these already available attributes. So I think we're still trying to figure out what are the ways to classify how to include human factors, but I think it can be broken into these 3. One way to look at it is to break it into these 3 types of inclusion. Adaptive, that means we're going to allow the meaning of the language to change depending on the person's context, on their background. You know, when Veronica, my student that worked a lot on this, liked to say when she says sick, she likely means something different than when her grandmother says sick. And of course, you can imagine when you know, from people from different cultures and whatnot, this is a huge problem. Then there's additive type of factor inclusion, where you're just trying to include the direct effect of the factor. Okay, so younger people are older individuals compared to younger. When you're distinguishing depression from PTSD, for example, the older individuals are much more likely to have PTSD. And then the third way is in bias correction. So in optimizing so as not to pick up on unwanted relationships between the output or the error of our models and human attributes. For example, maybe many of you are aware of some of the work on captioning, which has found, for example, that labeling pictures of men in kitchens, they're often more likely to be labeled as women, picking up on a bias labeled with female pronouns, on a bias towards seeing the kitchen and labeling in that direction. So on the adaptive side, one of the easiest approaches to do is inspired by domain adaptation, where this frustratingly simple domain adaptation by Hal Domain, where you can simply make copies of a feature for every domain. We looked at doing this, but we wanted to do it in a way where we could use continuous factors of people. And so, for example, a continuous gender score. So you have user factors, you have train instances, and the idea is you have your original features, X, you want to compose those somehow. You want to produce, first of all, the original features by themselves to allow for any features that directly can predict the outcome, but also you want to allow for adaptive features, and where we'll do a composition between the continuous valued score and the feature. And that composition could be as simple as just a multiplication, for example. And so the idea is, and this is one that I've also learned from psychology and social science collaborations, is although words, we model as discrete, they're pretty much discrete units. People, we don't want to put people into discrete bins. And a quote from Haslam 2012, most latent variables of interest to psychiatrists and personality, clinical psychologists are dimensional. I should also mention, while, there's a lot of, for the computer scientists, there are different fields this probably sounds obvious, but there are different fields within psychology, within the social sciences, and there's big differences, for example, between social and clinical psychologists and cognitive psychologists. I think a lot of our work in NLP has focused, it focuses a lot on the cognitive side because of the connection to AI. But a lot of the things we're talking about now are actually concepts more in the domain of social and personality or even clinical psychology. And so, you know, the obvious example is age. We've already talked about that. And so the idea is we want to be able to model people across this continuous dimension. And we found that when we do this user adaptation alone for tasks of stance, sarcasm, and sentiment analysis of documents, first of all, we get a significant improvement for including gender, including personality, and then for including the latent user embeddings, up to 3.4 increase in the case of sarcasm, which maybe, you know, if you think about it, might make sense. If you know your friend, if you just think about your friends and they send you a message, how much does your interpretation of that message depend on knowing that person, especially when it comes to sarcasm? And then when we looked at, go ahead.
Sorry about this, Andy. I wanted to inject a question here because it's very topical. There's been a question about general sarcasm detection and what one can do to detect sarcasm in general.
Yeah, I mean, it's, of course, this task is modeled at the text level. And so it's, you know, it's as if you don't know the person and you're trying to predict just from looking at the language. And I mean, I think actually sarcasm is going to be a long time till we can fully master that one. And one of the reasons for that is because as people, we do a terrible job at detecting sarcasm. If you want to be sarcastic, a nice thing to do is to mark your message sarcastic, you know, in emails and,
yeah.
and tweets.
And please help the NLP community by always using that. In real life as well, just always drop a hashtag.
Yeah. So sometimes some of these data sets use that to identify it. Others use human annotators, and there is a little bit of work showing there's problems with that because human annotators might not always do that well. So these accuracies here are actually against human annotators. So this is a question of how close can we do to a person? And we saw that when we use continuous factors, by the way, predominantly over the discrete versions of these attributes, they worked better. They have more power. We're not breaking things into arbitrary bins. I think I'm going to jump. So we can also do additive type techniques. And just quickly say, you know, the idea is bringing these into the model to just kind of adjust for a base rate sort of difference between factors. And so, I mean, this sort of diagram here gives you the idea of one approach to doing this we call residualized control, where you take a model that's just predicted based on the extra linguistics, in other words, the human factors. Sometimes, because we're in language processing, we call it the extra linguistics. And we get an error, and then the idea is to try to predict that error. And often by doing this, you can zero in on what the language can uniquely contribute. For those technically interested, it seems to give you the advantage of having different regularizations between your extra linguistics, which have very strong predictions, and your noisy language data, where the thing with language is oftentimes no individual feature is very predictive. Whereas with extra, you know, things like age and gender, things are. And I'll just say that you can combine the two, and you could read about that as well in a Zamani et al. Paper. And we're getting low on time here, but this shows the advantage in the case of doing county level predictions of combining residualized additive approaches and adaptive approaches. This is additive, this is adaptive, and this is combined. So I think I'll end with just as we also take these into effect, how can this help with model biases? And I think it can help us to better understand and define how our models become biased. When we start to consider, well, let's take into account that people have differences, and this is represented in their language. And one version, of such a biases, the Wall Street Journal effect, is this idea of the distance from the Wall Street Journal author demographics. Your accuracy goes down as you get further away. Why? Because the training data, you have a very different background than the training data. A different type of bias is exemplified by that captioning example I gave before, where the gender is mislabeled more often than even the training data has it. So we can look at these as an error disparity and an outcome disparity. And if we consider, the user attributes, for example, given a user attribute 1 or 2, an outcome disparity, we see something like this, where perhaps there's an ideal proportion and a result from prediction, and they have a dissimilar distribution across based on a given user attribute. And an error disparity, we can look at similarly. They have a difference in distribution, but now it's the error of the model. It works better for some people than people with a different attribute. And so we have a paper actually coming out in the ACL this year that tries to put this, builds on this, and puts it into a framework depicted here, where the eventual consequences we define mathematically, what can happen, how we can get models that in the end produce biased outcomes, and potential origins of those biases across a range of data, across a range of potential origins you see here in the standard supervised pipeline, where nowadays we're using embedding corpus, some sort of, some sort of features. And I would just, encourage considering looking at this framework. We're putting it out there. I don't think this is the ultimate framework, but we're trying to, as we've been working on, for example, selection bias and overamplification and semantic bias correction, we've been finding we need kind of an underlying conceptual framework as well as clear definitions to describe these. And so we're putting this out there as a starting point. This is with Dirk Hovey and one that my master's student, Devin Shaw, led this work. So I'll leave you with this. So again, what is it? Language is generated by people. Our data are inherently multi-level. We have already available human attributes. They don't even necessarily have to come from other sources of data, like surveys. Text, language gives us this. And our models are biased. And I think that the practical implication is if we leverage the people behind the words that we're analyzing, not only can we get more accurate models, but I think this leads to an increased fairness in applications, and increasingly human and social contexts that NLP is being applied.
Super, Andy. Thank you for the excellent talk. Super interesting, and I think we all learned a lot today about how both fields evolve, both the social sciences and NLP, through considering the overlap. So, okay, a few questions on the channel. So let's start with a simple one first. Why do the spam bots have such positive sentiment? Do you have a sense? Is it just a standard set of words they use? What is it?
Yeah, I mean, their average were, they're almost, yeah, we were seeing, you will notice you did not see a lower distribution of negative. So it's not that they're using less negative words. It seems to be that they are using just much more positive words than average. And so another thing, taking psychological science to computer science, there's a lot of evidence that positive emotion and negative emotion, while negatively correlated, are not along the same continuum. They are two different dimensions. And so I think that comes out a bit here. And in this case, the spam bots are they're talking a lot more positive words. I think they're probably programmed that way. Somebody's probably figured out people are more likely, to pick up on them, to pay attention to them.
Yeah.
But that's speculation.
Yeah, I mean, I think it's good speculation. Given that there is a literature in psychology that suggests that arousal induces action, and so So somebody thought, okay, let's make the spam bots very aroused. I could totally see that going through somebody's mind. Okay, so here's a cluster of questions, and it has to do with the feedback between our cognitions and our language. So we know this from the Sapir-Whorf hypothesis. So this is linguistic relativism, right? It's the idea that the language we shape, language and the concepts we have available to us in language shape our perception of the world and our cognitions. And so this is just a sort of general question to ask you to riff on it a little bit, if you can see evidence for Sapir-Whorf in NLP.
Yeah, I think it's difficult. I don't think, so what we see is reliable patterns in people's language that are associated with their attributes, or we could say, let's just take like their level of depression, their degree of depression. You can see reliable predictors now. Yeah, I mean, I think there's a lot of potential confounds to saying whether, how language use, if we're saying people's choice of language, we're asking how people's choice of language is then influencing who they are. I mean, the language around them, we'd certainly expect people are influenced by the language around them. I personally, I think there's interesting questions there. I think the closer you get to that, to something that predicts along those lines, like seeing certain language changes somebody. When you look for studies like that, the effect size are always much, much smaller than, for example, the associations between language use patterns and somebody's background, or language use patterns in a community's state of being. And so I think there's a lot of these cognition. I think in the intersection of NLP and psychology has focused a lot on the cognitive side, psycholinguistic side, which is incredibly interested, and I'm really interested in it, but I wouldn't consider myself an expert on that side. I think more people should be paying attention to the more personality psychology side, where we don't need to necessarily say, we don't need to understand completely what's going on cognitively to leverage individual differences between people, or differences between communities.
Great, Andy, thank you. So, and here's a very, very big question to end on. What do you think the role of NLP might be in the next election? Where does it play in ad spend? Where does it play in sort of making sense? What are the risks? What are some of the benefits? What can it do? What do you think?
Yeah, well, I do think our data in general, I think on the one hand, it's been a bit overemphasized on how much personalized analytics played a part in the last election. This is just me, as somebody who studies how we can learn about people from their language and reading up on that sort of thing. At the same time, I mean, I think it is power. We're seeing increasing ability, for example, to use these for personalized health interventions, for example, or to predict people's behavior, whether someone's going to relapse treatment. And that leads me to believe it's possible that it is pretty powerful techniques to look at people's data and make predictions about them. And I think it's increasingly important to move towards people owning their data and understanding when they're getting information, when they're being approached, it's catered to some sort of information about them. I think the GDPR goes along, from my reading of it, goes a long way towards that. In the US, we don't have something similar yet. But that would go a bit, if people knew when they're being presented with content that's catered to them. I think that would go a long way to mitigating any manipulative
impact
uses. Yeah.
Okay, so we're at time, but just a very, very final question here. What are some of the tools that you recommend for processing this kind of data? Is there perhaps a sort of open source package you could recommend, or?
Yeah, well, we use a lot of let me just first say, yeah, a lot of Python libraries. We some of the work we've done, we've even used. Johannes is setting me up to say that we have a particular package, Differential Language Analysis Toolkit, which is an open source package. It's been open for a while, but we actually just moved our master to GitHub because it was just hard to keep up. We had 2 versions of it, and so now it's completely GitHub public. And it's called Differential Language Analysis Toolkit, which has a lot of features that I believe are useful for understanding their users behind documents and communities behind that. But I use the Stanford Core NLP toolkits as well, a lot of Python, and sometimes even sometimes the simple tools, the linguistic inquiry and word count. For certain situations will give you good insights.
Good. I think we're at time. I want to be respectful of everybody's scheduling, given that we had over 200 attendees, up to 350 at some point. Thank you all for attending this morning, and give a big thank you to Andy for zooming in all the way from New York. Thank you very much, Andy.
Glad to be here. Thanks for your interest in our work.
Super happy to have you. Okay, so I'm gonna just take another 5 minutes if people want to lurk, to just ask you sort of second order questions that have come up here. People are asking for papers. I've tried to answer that in the chat. There's some sort of questions about what you meant by latent factors. I think it'd be worth perhaps saying again that these are these sort of atheoretical, right?
Yeah, the full name should be data-driven latent factors. When I'm referring to latent factors here, yeah, so often people will refer to, well, people's personality is a latent factor. And in fact, if you know the history of the Big Five, it was actually developed through data-driven factor analysis techniques. And I mean something similar to how those were derived when I'm saying latent factors, and that we're not ascribing them to any construct theory. Now, at this point, the Big Five personality factors has a huge literature base and theoretical side to it. And the latent factors we're using is just from, any latent variable model applied to language patterns across people. A user, some other folks have worked on user embeddings. If you were to use those, for example, and reduce them down to just 5 dimensions of user embeddings, that would be something on par with what we're doing.
Mm-hmm. Yeah, that makes sense. Mostly we've been doing this on American Twitter users, English-speaking users. What's the sample?
Yes, predominantly English-speaking users, and some studies increasingly trying to work with other languages. I think that's a big need as well. And it's not just cross-lingual when you go to another language; it's cross-cultural. I think there's a lot of interesting work to do there when you consider cross-lingual NLP. When you consider the human attributes behind that, a lot of potential benefits to be had by accounting for that. So we've probably Spanish and different versions of Chinese are probably we've looked into the second most behind English.
Mm-hmm. Okay, great. And then a few answers here in the chat. There's a GitHub repository. I posted it in the Zoom chat, and I also posted it in the response on Slido. WWBP GitHub, if you just WWBP, one word, and GitHub, if you just Google that, you come to a sort of master repository with code and our gold standard Twitter datasets that you can use. Yeah, okay, and then maybe final question before we sort of close this down, and also let Andy get back to his important work. Can you say one more thing about detecting humor, sarcasm, negation? How important is it, Andy? How important? Isn't everything we say ironic?
Yeah. How important is it? I think these are specific tasks. I'd say the important thing is understanding people behind language. These are examples. We can't even understand the meaning of words. You know, these are levels of understanding meaning. I think they speak to this quote. I guess I'm not still sharing my screen, but I think they speak to this quote from Clark on you know, that meaning has to do with people, what people actually mean in the end.
Mm-hmm.
And you can't really, I think the fact that we get benefits from these techniques that just consider people's users' background suggests that you know, they mean, their background influences what they actually mean.
Mm-hmm.
Their user attributes are helping us to better understand what they mean. So sarcasm is an example where we can better understand someone if we can do better sarcasm detection.
Mm-hmm. Okay, great. I think that's it. There's a few open questions here in the chat. Many of them are answered by looking at dapwp.org, looking at the GitHub page, and going through the publications on dapwp. They tend to be small and technical, like the question about the inter-class correlations. These are, I think, a little bit too technical for a general chat. So thank you very much, everyone, and have a wonderful rest of your day.
Thank you all. It's a pleasure to speak with you.